Hello, welcome to my YouTube channel. If you're watching this for the first time, you're just on the right channel. This is Zui Academy, where we are doing technical drawing. Now we are going to look at to revise a paper here for civil engineering level 6 from Siaya National Polytechnic, and it's a simple one. It's just a cut, and let's see how we can embark on it. Now question 1, we just want to identify some of the drawing instruments used in technical drawing, their purposes and their maintenance, and possibly to sketch them. So now first we can have the column for serial instrument, the purpose, and then the maintenance, and now the sketch. Now first we have the first equipment here, and this is called the pair of compass. Now a pair of compass is normally used in drawing or transferring measurements, and we can also use a pair of compass to draw arcs or circles. Now maintenance here, you need just to fix the screws so that they don't loose or drop off. And I just want to do a sketch here. Don't mind so much about the sketch. I'm just doing a sketch, something similar to a pair of compass. Okay, now next we have the T-square. A T-square here is normally used to draw or construct horizontal lines, straight horizontal lines, and we can have it stored in packages so that it doesn't develop scratches, to avoid developing scratches. And we can also have the calibrations. And next we have the set squares. Set squares are used to measure angles in drawing parallel lines and also measuring angles. Angles like 30, 60, 45, and 90 degrees. Again, we need to store them in packages so that they don't again develop the scratches. And next, we have a protractor. And our protractor is normally used in measuring angles. And we also have to store them in their packages to avoid again scratching. This is just my illustration. And next we have the French curves. Now French curves are used in constructing or drawing curves. Keep them safe in the sets. Okay. Now let's look at question number 2. Question number 2, we are expected to draw an ellipse given the major axis and the minor axis using concentric circle method. So in this case, we are going to have two lines that are going to cross each other perpendicularly. These ones we are calling them the axis. Now in these lines, we shall draw two circles which are concentric, one using the major axis and another one using the minor axis. So these ones perpendicular lines that cuts across each other. Now the first one is of radius 60 because diameter is 120. The major axis is 120, so it's 60. That's the outer circle. And the other one, the inner circle that is drawn using the minor axis, that measures radius 40 because it's equal to 80. We draw it again. And these ones are concentric circles, the inner and the outer. Next, we are going to divide this circle into 12 equal parts. Now, in this case, we use a 30-degree set square and a 60-degree line. So this is a 60 degree line, another one, and then we also have a 30-degree line. We interchange and also draw another 30-degree lines. This is how we divide circles into 12 equal parts. So let's elongate this line to cut all the two circles. Ensure these diameters are cutting all the circles. We are calling this diameters. Now remember, these diameters are cutting the inner circle and the outer circle. So where they cut the outer circle at the inner circle, we draw horizontals. We draw the horizontals from all the points of intersection, the sections. Now where they meet the outer circle, we draw verticals. Now verticals will intersect with horizontals to give us some points. On those points, we shall draw a curve. So this vertical meets this horizontal, this one, and this other one meets it here. We drop it, and this other one meets there. Interchange and draw the lower part of it. Ensure the T-square is horizontal. Again, on this other side, we drop it. We drop it vertically upwards. So horizontals meets verticals. That much. So these points will be joined with a fine curve, and use a free hand to just draw this curve. So I'm just trying to do a guideline, so that this guideline, we are going to have a line drawn through it to give us a curve, and this curve we call it an ellipse. So now you can complete using a visible line. So there we go. This is an ellipse. Now next is we are going to draw a parabolic arc within a rectangle that measures 1000 by 800. So the scale is, we have to use a scale that is going to fit in our paper. So where 1000, I'll use 10. That's a scale of 1 to 100. Where 800, I use 8. So this is a rectangle. Inside, we are going to draw a parabolic curve. Or in short, we are drawing a parabola inside a rectangle. So you can stand here and cut, and also come here and cut. Join the 2 points with a straight line. And this gives us a full rectangle. So we now divide this rectangle into 2 halves. In the middle, we bisect the side, the length. And when you bisect, we get the 2 halves. So one of the halves, we can name this as MN. One of the halves, we divide the base into equal number of parts. Let's divide into 4. So these are divisions. We can elongate this line. Rejoin this last point to the last mark. And we transport these points to our base using 2 set squares. Now we can number as 1, 2, 3. So the same thing could be done on the left hand side of that first half. We divide it into equal number of parts, 4. This one is going to be so far away, so we can reduce by dividing again into equal halves. So let me just bisect, because so as to get equal intervals. So at least I'm reducing this one into half. So we can now use this one as our division. 1, 2, 3, and 4. So we join the last point, the last mark, again the same way we did with the lower part of the first half. We now again transport these points to our line. And now we can number as 1, 2, 3. Now using this, we can using a straight edge, we can as well take these divisions to the other half, second half. And we number again 1, 2, 3. We draw lines, radial lines from N through 3, through 2, and then again through 1. The same thing can be done on the left hand side, through 3, through 2, and through 1. Next, we are going to again move these other points to the right hand side, and we number them from this corner 3. Now again we draw lines from the base to meet these lines, that the radial lines, so that 1 meets 1, and then now 2 meets 2 up here, and then 3 meets 3 up here. Let's do it on the left hand side. 1 meets 1, then 2 meets 2, and then 3 intersect with 3. So through these points, we draw a curve passing through all those points to the top. And then we can complete in that manner, in this manner. Proceed up to the vertex, then drop downwards back to the first corner. So this one here is a parabola, parabolic curve inside a rectangle. Next question, we're going to do orthographic views in first angle projection of the solid figure given. So you first of all have the cross, again the layout, and the layout here we shall have two lines crossing each other, object lines crossing each other perpendicularly. So we can have guidelines again, this other side, a guideline, and then also another guideline on this other side. So we elongate this, we also extend this, extend upwards. This other one, okay. Now the front elevation shows a curved, and then the base that is rectangular. So we are going to have two faces meeting each other. The first one, now the whole length upwards, you ensure you measure. I'm using a scale of half of the measurements here because of the size of the paper. Now the lower part here is 26, so we use 13. The semicircular solid is centrally placed, so we get the midpoint. We can as well bisect. So this one gives us a bisector. We draw it. It gives us the central point. So we take the radius and we draw the semicircle. These two faces meets to give us the front elevation. Now for the plan, we project from the front. Let's have projection lines downwards. the plan is we are observing the semicircular solid from top and the base is rectangular. Remember, I'm using half the scale. So we get the central point because we are placing the semicircular part on the part of this solid in the middle. So this is the center line. And this face here is 26. So we get 13. So from the center line we measure 6.5 below and 6.5 above. That's 6.5 millimeters. So we complete the semicircular solid from top. That's how it appears. Now the base is just a rectangle. Whereas the semicircular from top appears to be a rectangle as it is. Now let's draw the end elevation. From the left hand side you draw the front elevation on the right, that is in first angle projection. So let's project this line. So project this line again, also project this other one. So now we elongate this upwards. There we go. There we go. Now we complete our end elevation by joining the base so this is the end elevation. Good, let's proceed to this one is the end elevation as it is. Now let's see, this is point number 4. We can now move to the next question, which is of course the last question. We're going to draw a cuboid that measures 120. This cuboid here, we are going to draw it in what you call cabinet view. So we identified the lower point 120 by the breadth of 55 and the height of 40. So this on the oblique view we take half the distance. So oblique, we have to draw a 45-degree line that is on the oblique side. And this oblique side, remember on the original question it is 120, so you need to take half the distance, and half the distance is 60 millimeters. So pick 60 millimeters instead of 120 and mark. So you can draw the vertical face. Remember the base here is 40, so we bring 40 millimeters. We put it on the base is 55, the height is 40. So breadth is 55, you measure 55 and just bring and mark it here. We are drawing in cabinet. This is a cuboid we are drawing in cabinet view. It's oblique type of drawing. In this case, we take half the distance on the oblique side, but we maintain the frontal elevation, the frontal face, the measurements on the front. So we just complete to give us the expected solid. So we are joining. Thank you. This is what we were supposed to draw. This is the drawing in cabinet given the breadth, the length, and the height. Thank you very much.